Hey everybody. We're going through some basics of the nervous system. We're looking at the brain in a general way, and now I want to just kind of get in there and jabber about brain waves. So this is part one of that, and I'm Elisa, and let's get started. So the thing about a brain wave is like we don't actually think your brain is in your skull, like jiggling around and stuff, right? It's not doing that, but we do think what's happening is and we do know is there's like little electrical impulses going back and forth through all these little neurons, right? And we know that because well, we're able to actually, physically interrupt them and monitor them using action potentials. And so like all of those, like, highs and lows are something that we can monitor um, electrically using an electroencephalograph, right, your brain gram. And the gram means we're going to make a drawing of it. So electroencephalogram means it's a drawing, right? Here, it's a drawing of the electroactivity in your brain. And so we're going to look at these drawings that are going to tell us about, let me get all that. That's like so much stuff over there. Okay, so it's going to tell us about all of this activity, this neuronal activity in the brain, because we're going to look at where it's active, we're going to look at how active, we're going to look at like the patterns of activity. It's going to tell us a lot about brain function. Okay, so we're able to do things like diagnose lots of different disorders, including things like epilepsy, which have disruptions, spontaneous disruptions, as well as also sleep disorders. And sleep monitoring brainwave patterns is absolutely essential for successful sleep, and sleep is essential for living. So, super important stuff. It also helps us whenever we see like kind of dead spots. It helps us look and see if we have lesions, which are like damage points, maybe tumor growth, infarctions from stroke, or even infections, hence abscesses as well, because those areas are not going to show activity, right? They're going to be like these kind of dead or low activity zones. Mostly. So we're going to use this in research, which is super duper fun, but also it helps us determine when someone is technically brain dead as well, right? Because we can do a lot these days with medicine, but we have yet to bring the brain back. We can do a lot otherwise. So since we're going to study the electro activity of the brain, we're going to use some electrodes, and we're going to stick those electrodes on the scalp. And that alone is actually enough because there's so much charge activity to look at those action potentials, right? Those potential differences in the cortical areas, meaning like when one part of your brain is like active and then another part of your brain is like sleeping or not as active, for example. Not really sleeping, that would be amazing, but really just not as active. Okay, the wave patterns that we're going to look at fall into the categories of alpha waves, beta waves, and theta. So the alpha waves are in the range of generally 8 to 13 hertz. They're regular, they're rhythmic, they're low amplitude for the most part. They are synchronous, and this is your brain zoning out. This is your zone out. You are just, this is your zone out. This is like your meditation happy place. Beta waves start jumping in at 14 to 30 hertz. So these are going to be, although rhythmic, they're less regular. So what we're doing is we're showing parts of the brain starting to like toss ideas around and change thought points and patterns. You're starting to activate more parts of your brain. You're having that crisscrossing effect. What's interesting is then we go to these. This is an interesting one. That's the theta wavelength. So these are 4 to 7 hertz. So as you see, we took a dive. They are irregular. Um, they're not common in awake adults, but they're gonna be in your kids. So I love my kids with all my heart. But I think if you have kids, you can definitely see this, and it's the reason why you can say, can you put your shoes on? We're going to go out the door. I just said, can you please put your shoes on? And then they're over there and they're playing with this toy on the ground, right? And they're just being adorable, and then they like make a sincere effort, and then they get sidetracked, and the next thing you know, they're like, "Ooh, it's a cookie." And then you're like, "I told you to put your shoes on. We're going to leave." So you start this like 10-minute process, and a lot of it might be this theta waves. I call it butterflies. Like, you tell them to do one thing, but they get just distracted by all the butterflies in their life, right? They got to go follow them, and they just can't physiologically focus. So hopefully that gives you a little more patience with those little ones. It's not their fault. It's just their biology. All right, delta waves are the last category. And so these are the deep waves of sleep. So they are delta 4 hertz or less, right? So these are high amplitude. They really get up there in deep sleep. When we have our RAS, or our reticular activating system, right? We call it the RAS engaged. This is going to be, and we look at this in another video, so this is what controls like the wake sleep cycle, and a lot of it is light mediated, right, for our circadian rhythm. And so this is going to be when our rousing RAS is letting us just remain suppressed and let us sleep. This also is shown up in anesthesia, which is tricky. Like, as much as we'd love to know more about anesthesia, we don't know entirely as much as we probably wish we did. However, if we do see delta waves in an adult, that's going to indicate brain damage. So after trauma, delta waves, yeah. So stroke, for example. Here's what they look like. This is the electroencephalography. Right. So here's the graph part. Right. I was thinking about graph of the EEG. So these are the brain waves. So here is you meditating. This is you zoning out. This is a good place to be. A lot of people feel pretty guilty about being here, but no, it's a good spot. Beta waves. Oh, okay, I'm going to read this. Oh, wait, did I remember to? Oh, wait, yeah, I'm going to go. Wait, why is this happening? You can see the movement of thoughts even here. And this is also, maybe the fits and starts of the body as well. Like, oh, I'm going to move over here. Oh, that was heavier than I expected. Oh, you're just going to push really hard, So theta waves, again, these are common in children. These are the butterflies, right? So this is your butterfly zone. So please be patient. Those little butterflies, it's not their fault. Their brains are forming. And then here are those, when I said high amplitude, there it is, high amplitude delta waves, like the pits and the valleys of that delta, and you can just see it going up and down and up and down of those deep sleeps, right? So RAS is suppressed. This is like dark room, super sleep. Okay. So, we talked about brain activity. We talked, we talked about all these different states, and so we talked about calm, and we talked about more alert, states, and then we talked about deep sleep, like where we were pretty much offline, and then that kind of brings us to this idea of consciousness. And so the idea of consciousness is going to be explored a little bit more in some other videos, but it's actually really important diagnostic criteria. So I'm not going to get into those entirely here. We definitely do when we talk about pathophysiology, but really it's the perception of sensation and also response to it, right? So that technically is and there's different levels for that, and they have these kind of, I don't know, I feel like they're a little gray area, but they're probably not really as much as I personally kind of feel they are. I'm sure if you're I've had my EMTs tell me they can really tell the lines and differentiation between all of these. It's perception of sensation. It allows you to control movement, respond. So some of these are going to be like memory, logic, judgment. What's your name? Who's the president? What day is this? Right? How many fingers am I holding up here? Can you walk this line? So it talks a little bit more about how you're mentally processing information, sensory information. So it is, like I said, some folks in their clinical daily life are using it all the time, especially on the EMT's emergency scale folks. So it's a continuum like where, you start off as, conscious and awake and aware, and then you end up all the way through like the worst parts, including things like coma and whatnot. So they grade your behavior into your response to different stimuli or questions, like logic questions. They're checking you for how alert you are, or how tired or lethargic you really are, or are you able to move around just completely uncoordinated, and or have you lost the ability to coordinate your movements and no longer respond to stimuli but still remain alive, right? So brainwaves are important in determining all of these and can be associated with ways to look at this. These are some initial diagnostics you might use to investigate it later on, see what types of EEGs you might be wanting to kind of move forward with. All right, so I hope that gave you some basics, and I hope that was helpful, and have a lovely day.